Thank you. So, hello everyone, or should I say Helio everyone. My name is Ben. Bit of my background, I've been doing web development for a number of years. I started using Django in 2007-ish. Previously worked for two of the other PyCon gold sponsors, so shout out to the guys from WebDrive and some. And currently working for Yellow. So at Yellow, we needed to develop an interactive web-based application. And we wanted to leverage the best parts of Django and JavaScript and CSS. And of course, what we built needed to have good performance and also be quick to develop for. So the framework that we developed and built this application on is called Helio. So I've got quite a breadth of stuff that I'm going to cover. So at times I might not go into too much detail, or it possibly might not fully make sense. But as I cover all these topics here, hopefully all the gaps should fill in, and by the end of it, you'll have a good understanding of what Helio is. So to start off with, Helio is componentized. Now, to understand what that means and why we chose to do it this way, we need to look at the current state of JavaScript frameworks. So the way you currently have to sort of set them up, and this is the case with your Angular.js and your backbones, is your Python framework will expose a REST interface, and then it will shoot JSON across the wire at your JavaScript framework, which will interpret that, turn it into HTML, and then put it into the right place in the DOM. So you end up writing all your templating and all your models in JavaScript. So Helio takes a different approach by keeping the HTML generation in Python. So small snippets of HTML are sent across the wire to the Helio JavaScript framework, where they're interpreted, inserted into the DOM, and then JavaScript and CSS are attached as needed. And this means you get to keep all your tasty Django bits that you love, so your models, your form validation, and all your template rendering. So this is a real simple Helio application that I've built as an example. And we keep the HTML transfers light by breaking the page into sections, or as we call them, components. So this page has a header component, a menu component, a document component, and a footer component. And each of these can be updated independently. So to go into more detail of what exactly a component is, I'm going to be concentrating just on the menu. So components are all self-contained inside a directory. And for the menu component, it looks something like this. You have your init.py file, because each component is a Python package. You have your template, and for the menu, it looks like this. And this is only rendering, it's only used to render the small menu on the left of the page. We also have a Python ViewController. Now, the Python controller defines JavaScript and CSS files. It will respond to notifications, either from the browser or from other controllers. It will retrieve data, like from a database. It will generate the template context and feed it off to the template to be rendered. And for the menu, it looks like that. So the important part to look at here is the component name, and that tells Helio where to find the component on the disk. And these two other arguments tell Helio whether or not that component has JavaScript and /or CSS. And the CSS and JavaScript files live in that directory, in the static directory. A menu.css looks like this, and it's only used to style the menu. And it's only loaded into the DOM when a menu component is loaded onto the page. And when no more menu components remain, it's unlinked from the DOM. Similarly with the JavaScript, it's only loaded into the page when there's a menu component, and we register it, and it can be reused every time a new menu component is loaded. And we have an attach function which gets called, and there you can do all your standard JavaScript event handling stuff. So here we're just doing an on-click event, but you can do anything. So that's what a component is, but how do multiple components all work together? So I missed out a component before when I showed you this, and that is the page, which contains all the other components and itself as a component. So the PageViewController from Python, you can see it's creating a header, a menu, a document, and a footer, and attaching it as a children to itself. And the page HTML looks like this. So we define container elements, and we render the templates of the children there. And to identify the children in the DOM, the divs are given IDs, which is set to the controller tree path. So more on that in a minute. So to keep track of where all the controllers are, we keep a ViewState tree on the server. So for that page, it looks like this. But we need a way to identify each controller inside the tree. And we do that with a dotted path. So any controller here can have any number of children. So I've only got a 2-tier one here. But if we add a new controller called page1 and add it as a child of page.document, it gets the path page.document.page1. But don't use that in this example. Now, there might be some confusion about the name of a controller or component versus its path in the tree, because in this example, most of them are the same, i.e. page controller is at page, and page.menu has a menu controller in it. But that's not always the case. So we have here blue controller at page.document. That means that we can have a tree path remain the same, but replace the controller at that instance. So something like this, we can replace the blue controller with a red controller. And the browser will communicate with the server to start these changes. But saying that it communicates is a bit nebulous. But that brings me to my next section. All communication with Helio is done with notifications. So if we take the example of, I want to click something in the menu, and it will change the blue controller to a red controller, the notification flow looks something like this. A user clicks in the browser, and the JavaScript controller catches that event. It generates a notification and says, the controller at page.menu needs to respond to a menu change event with the data red. That gets sent to the Helio Notification Center. That will broker the notification. It will look up the controller that's to receive that and say to it, you need to handle a menu change event with data red. So on the menu controller, we call the handle notification method, and we pass in the notification name and the data. The menu controller will then create a new controller and insert it at page.document. So now on the server, the view state looks like this, but in the browser, it will still be displaying the blue background. So we need to tell the browser that it needs to update that portion of the page, and we do that by queuing a controller refresh that gets sent back to the client. So the flow of notifications back to the client looks something like this. The Python controller will generate a notification that says, page.document needs to load, and this is the data it should load. That gets sent to the notification center. Now, as part of the request cycle, any number of Python controllers can do stuff and send out notifications. So they all get queued up, and at the end of the request, when the response goes back to the client, they're all sent out. The client will interpret each of those and look up the right place in the DOM and put the HTML there, as well as set up any JavaScript or CSS that's also bundled. And then we get something like this. So we can also, with this setup, do server-side only notifications. So we implement the observer pattern, which means any controller can subscribe to any events that it's interested in. So these two controllers on the right both subscribe to notification A, and the lower controller also subscribes to notification B. Then if any other controller sends out notification A, it gets brokered to both on the right. Similarly, if a controller sends out notification B, it only goes to the lower one. Notifications can contain data, or they can simply trigger an event. So for example, notification B might say to the lower controller, you need to update your data and then tell the client that it needs to update. So the lower controller will send out a load notification, which goes off to the client. So in practice, a server-side notification could be used something like this. So this is a controller that adds two numbers together and displays the result. So I can enter two numbers here, and when I click Add, the form is posted to the server, the two numbers are added, and the page is re-rendered with the result and returned. But you'll notice that the result also appeared at the bottom, even though it's a different component. So the heliomath controller is what's doing this addition. So it adds the two numbers together, and then it sends out a result. It sends out a notification called with the name of result with the data as a payload. Notice that the notification hasn't identified any targets. Then on the footer controller, we've subscribed to this notification, and when it comes in, it will store the result on itself, and then on its next load, update its context to render. So you might have noticed on the heliomath controller, I'm doing form.isValid. And this is one of the tasty Django bits and pieces that I mentioned earlier, and brings me to my fourth section. So with Helio, we can easily integrate the Django form validation, for example. So the JavaScript that for the heliomath controller, all it does is serialize the form and submit it back to the controller, where we have a numeric form, which is a subclass of a Django form. So we can instantiate that with a bit of massaging, pass the data in, and use normal Django validation to validate that. And then we can do standard happy path or sad path stuff. So happy path will be stuff like creating a new controller and pushing that into the view, or sad path is usually just to reload the form and show the errors. So in practice, I can put in some bad data into the form, click submit, and it refreshes just that component to show those errors. And you probably also saw I was doing a context setup. So if you've used different Python template renderers, you'll know they sort of differ quite a bit in their execution. In fact, most Python web frameworks differ quite a bit. So how can we integrate with different frameworks? With Django, it's easy. You tell Helio to use the Django renderer. You add Helio to your installed apps and your URLs. And then you add our static files and template loaders to Django. And by the way, the component static finder works fine with your Django collect static, so it'll find all your static files and put them into your web root for deployment. We also have Flask integration. So that's sort of the opposite end of the spectrum from Django's full fat, include everything approach. Flask, very lightweight, bare bones. But you tell when you're integrating a Flask, you tell Helio that it should use the Flask renderer, which is actually a Ginger renderer, as you know if you've used Flask. And you tell your Flask application to include the Helio blueprint. And that's all there is. Okay, there's one more thing. The Flask doesn't actually use Pickle in its default session serializer. So you're going to have to write your own one of those. It's only a couple of hundred lines. Looks like that. Hopefully it's readable at the back there. For other frameworks, we have a sort of a standard interface. So you just need to get your framework to route the URLs for getting a view state, retrieving the controller data, and receiving notifications from server. So Helio will tell your framework how to find templates and static files, and you tell Helio what renderer to use. So integrate with your favorite framework, provided it does sessions and URL routing, and you can post data with it. But doesn't all this overhead make your web apps a lot slower? Well, not necessarily. We take this example here. So this is a list of 10,000 random strings. And when I click on any of those, it'll show the string that I clicked on at the top. So it's a very simple example of a master detail controller. So I wrote this in Django, using just Django. And every time I click on one of those results, it has to reload the whole page, re-render that entire table, just to refresh the part at the top. So initial load for that page is about 1.7 seconds. But then each subsequent load takes about the same amount of time. I then rewrote it in using Helio. And I could break it down into two components, a master detail view at the top and a table view at the bottom. That means that when I want to refresh it, I just need to refresh the component at the top. So you can see using Helio, there's about 4 requests to get the page set up, and it takes a little bit longer. But after you've done that, all you're posting is a detail update notification back to the server. And that's very lightweight. It's only 138 bytes. So when you're doing multiple page loads, with Helio, it's relatively flat. And with Django, the extra time quickly adds up. It's a similar story with the cumulative data transfer. It's about 2 megabytes in total for Helio, and using Django by itself takes off again. So I showed you before a 2-tier web-based Web 2.0 calculator, and that's pretty enterprisey, right? But how does Helio work with a real application? Well, at Yellow, we use Helio as the basis for our Axel application, which is a system we've built for product management, order capture and deployment, and provisioning, and workflow delegation. So it uses a reverse mullet architecture with a party in the front and business in the back. So Django and Helio provide the front end, and they communicate using XML over HTTP to Java Web Services, which then store data in an Oracle database. And this is a screenshot of what it looks like. And you can sort of see how we've componentized it. There's a menu on the left, a header at the top, a document view, and there's a sidebar on the right, which is currently hidden. So having everything componentized made independent development very easy, as each developer could just work on the component, on a single component, but they could be confident that when they combined it with the rest of the system, that everything would work together. And this is an example of an order capture form for item configuration. So the form has been submitted with errors, and we can just use the Django standard form validation to generate that error. And then when we refresh the page, we're only refreshing what needs to be changed. Helio encouraged us to be able to, well, allowed us to do reusable and easily configurable components. So here's an example of a discount search screen. And because of the metadata-driven nature, all those search fields at the top are actually defined from the Java services, which means that on the Python layer, we can just change a single argument, which is the type of thing that we're searching for, and instead of getting a discount search form, we're now instantiating an order search form. And as well as encouraging code to be very dry, component reuse meant that enhancements to base components magically appeared throughout the entire system. So one day, we decided that we needed to have sortable tables. And so we added the sorting to the base table view controller. Then every other table in the system magically inherited that and became sortable. Server-side notifications allowed us to easily implement things like the shopping cart clearing function. So upon clicking the clear button, the cart component will send out a cart cleared notification with the current order ID. And if the order detail view in the background is currently displaying that order, it can refresh its data and indicate that it should be reloaded in the front end. But if that order detail doesn't exist or it's showing a different order, then that notification is silently dropped, and we don't need to do any checks for when we send it out or make sure that the right component is going to be listening to it. So this is kind of a dirty word, but it's not like we're sending huge amounts of data back and forth to the browsers. This all works via your session cookie. And we found in practice in Axel, session size is only around 60 kilobytes in size. It depends how big your view's getting in that, but they're relatively small. But we actually had more trouble caching multi-megabyte XML documents in Memcache than we had dealing with Helio sessions. So, to finish with, Helio is open source. So you can jump onto GitHub, get the code from there. Obviously, we'd like to integrate some more web frameworks, so if you have experience with Pyramid or something like that, I'd like to hear from you. Code's all there. It doesn't yet have a README, so hopefully next couple of days we'll get some more instructions up there for how to integrate that. But if you want, you can download it and try to get it working. Yeah, thank you.